Now, please allow me to invite our next speaker, KUDO Junichi, Chief Researcher, the National Institute of Maritime, Port and Aviation Technology, to speak on application of a dynamic task-based hazard identification method to remote operation of experimental ship Shinpo. So Junichi-san, please.
Good morning, good afternoon, or good evening, everyone. My name is KUDO Junichi. I am working for National Maritime Research Institute. Today, I make a presentation on application of dynamic task-based hazard identification method to remote operation of experimental ship of Shinpo. Recently, technological development related to automated ship have been progressing worldwide. Thus, it is essential to ensure the safety of these ships for their successful realization. In previous studies, task-based hazard identification methods were developed as safety assessment method for autonomous ships to identify the hazard. However, these methods only focus on the static aspects of the tasks. Practically, important aspects are the dynamic characteristics, such as the sequence or timing of execution, the time required for an individual person to perform task. We propose a dynamic task-based hazard identification method that introduces a task flow diagram into a previous method. This study reports the result of applying the DTB-HAZID method as a safety analysis method to a remote operation of a small experimental ship Shinpo. In this slide, I will introduce an experimental ship Shinpo. The control system of Shinpo consists of three systems. The first system is ship control system. This system is basic system to control actuators using a program logic controller. Another system is waypoint navigation system. This system automatically steers the ship to a target course along predefined waypoints by controlling the radar. The other system is remote control system. This system connects the ship and remote operation center via LTE communication to enable remote control. This slide shows the overview of remote operation center. These two monitors show the image from the onboard cameras, and the right display monitor autonomous ships to identify the hazard. However, these methods only focus on the static aspects of the tasks. Practically, important aspects are the dynamic characteristics, such as the sequence or timing of execution, the time required for an individual person to perform task. We propose a dynamic task-based hazard identification method that introduces a task flow diagram into a previous method. This study reports the result of applying the DTB-HAZID method as a safety analysis method to a remote operation of a small experimental ship Shinpo. In this slide, I will introduce an experimental ship Shinpo. The control system of Shinpo consists of three systems. The first system is ship control system. This system is basic system to control actuators using a program logic controller. Another system is waypoint navigation system. This system automatically steers the ship to a target course along predefined waypoints by controlling the radar. The other system is remote control system. This system connects the ship and remote operation center via LTE communication to enable remote control. This slide shows the overview of remote operation center. These two monitors show the image from the onboard cameras, and the right display monitor shows ship position information on electronic navigation chart. The console with touch panel display provides ship control system and waypoint navigation system information, such as ship status, command and response values, waypoint settings, and system error warnings. And a voice guidance speaker also provides a waypoint navigation system information, such as approval requests to the remote operator. In our institute conducted experiment of remote operation of Shinpo in the last April. The experiment site was in Inland Sea area around Inoshima Island of Hiroshima Prefecture. Remote operation center was in our institute, Mitaka City of Tokyo in Japan. The distance between remote operation center and the experimental site was about 600 kilometers. The planned route is shown here. It was approximately 20 minutes one way with 7 predefined waypoints. The target of this study was remote waypoint navigation. In the remote waypoint navigation, steering angle automatically controls, while judgment of collision avoidance and control of engine were conducted manually by the remote operator. We observed the experiment, organize the task of the remote operator, and specifies sequence of operation and relevant information. We identify the following main tasks of the remote operator: maneuvering, watchkeeping, positioning, and system monitoring. The main tasks were divided into multiple subtasks, which are composed of detailed activities performed using cognition and human behaviors, such as gathering information from camera images and sensors, decision-making, and system operation. The task flow diagrams were generated based on the system specifications, the observation of the experiment using the videos, and result of task analysis. The figure shows the task flow diagram of the task of maneuvering. The diagram composed of two partitions, that is systems and the remote operator. The table shows the notations. These notations the same as activity diagram, that is a type of behavioral diagram in the unified modeling language. The introduction of the activity diagram notations into the task flow diagram made it possible to represent parallel processing of the tasks, and it facilitates the identification of hazards produced by the simultaneous execution of the tasks. With reference to the task flow diagram, dynamic task-based hazard identification was conducted from the viewpoint of deviations from the normal procedure and status, such as incomplete task execution, failed task execution, swapping the order of the tasks, and the deficiency in information due to equipment failure. And dynamic task-based HAZID was conducted using a structured what-if technique method in a HAZID meeting. From the results of the dynamic task-based HAZID, 30 hazards were identified, including some duplicates. The table shows the example of hazards. The first hazard was that necessity for collision avoidance against other ship is mistaken. Cause of this hazard were that remote operator cannot identify the ship and so on. Possible additional safeguards to this hazard were utilization of radar and automatic tracking function. The next hazard was that means of collision avoidance other ship is mistaken. Cause of this hazard was that remote operator cannot predict ship's behaviors. Remote operator cannot determine the necessity for collision avoidance promptly, or among multiple ships, the wrong ship or means are determined for the collision avoidance. Possible additional safeguards to this hazard were understanding of performance of Shinpo, or utilization of radar and automatic tracking function, and so on. Most of hazards were caused by mistaken in handling previous tasks, incompletion of the previous tasks, and the lack of necessary information needed to perform the task. From maintaining the safety of the remote ship maneuvering, it was suggested that each task needs to be performed smoothly, and information from systems should be correctly presented to the remote operator. We analyzed task and information flow of the remote waypoint operation of a small experimental ship Shinpo. Based on the results, task flow diagrams that use the notation of the activity diagram are presented. By using a task flow diagram, it was possible to identify time-related hazards, such as task delays and simultaneous occurrence of tasks. The proposed dynamic task-based hazard identification method may help analysts understand the task flow of the systems, including the human activities related to the system procedures. The proposed method may facilitate hazard identification for risk analysis, and it will contribute to enhancing the safety of autonomous systems, including remote operation systems. Thank you for your attention.
Thank you so much for a presentation, KUDO Junichi. I don't see questions on the pigeon. Now, can I ask the floor? Is there any question to Judo, please? If that's the case, Junichi, can I ask you a question about, I think in your presentation, I have a question on your communication channel. So you said LTE. LTE was used to control the vessel.
Yes.
So is LTE wide enough to accommodate all the communication between the shoreside and autonomous vessel?
Yes,
and
right.
is there a specific reason why you decided LTE for that?
Oh, this is an experimental ship, so the LTE is a general means to communicate the ship between remote operator center, and traffic speed is limited. So this method is this method is reality has a reality. Is it okay?
Yep. Okay. Thank you so much, Junichi. Thank you for your time.
Thank you very much.